Okay, in this video we're going to work on simplifying radicals. So let's kind of talk about a radical. A radical has to do with like a division sign, but with a little check mark on the end of it. Okay, this is called most of the time we call this a square root. And the reason why we call it a square root is because we don't see anything in what we call the index. This right here is called the index. That's the little space in between the two little lines there. And when we don't see anything there, it's just like your age. When you say you're 14, you're really positive 14. So when we see this little symbol, we normally call it a square root. And so there's really a little 2 there. We just don't see it because we call it the square root. So the index is a 2. And if you remember, square root really is asking us what number times itself gives us the number inside the square root. That's what it's really asking. All right. And so that's what it's really asking. So when we have a square root, we're just wanting to know what pair of numbers that are the same will multiply together to give you the number inside the square root. So the simplest ones, like 25. What number times itself, or a pair of numbers that are the same, that'll give you 25, and it should be 5 times 5. So your square root is 5, because you want to know what number is it. All right? So that is the index is with the number between there. Now that index can change, and it does change. And so sometimes that index can be a cube. It can be anything really. So we could actually have a 3 here inside here, and it would be in there, and that would be a cube root. Excuse me. And so the cube root would tell us what number times itself again. So what number paired off 3 times would be the number inside the box. So let's do 8, for example. Let's say I have a cube root of 8. I want to know what number times itself again, so otherwise 3 times would give me 8. And so what I normally do is I ask you to do a factor tree. So think of an 8, and what 2 numbers multiply give me 8? 4 and 2. And then keep breaking it down to its prime number. So what 2 numbers give me 4? 2 times 2. And I always bring down this. Now some people say, oh, 2 times 1. But you don't need the 1, because anything times 1 will give me 1. Or give me that number, so you don't need it. Alright, so I'm going to look. And then if it's a cube root, you want to group them in groups of 3. See how there's a group of 3 2's here? And so because of that, you know 2 times 2 times 2 is 8. So the cube root of 8 is 2. So my answer here would be 2, because it's a number that can be, there's 3 sets of them that will give you the number inside the cube root box. All right, so let's do a couple of these, and I'm telling you, doing the factor tree does help a lot. So let's take something like this. All right, now we're just going to do the square root of 27. All right, so now I'm going to do the factors of 27. 27 is 9 and 3, and then 3 times 3 times 3. All right, notice the index. The index is a 2. All right, so we know the index. Remember, the index is a little number that's between there, and since we don't see it, we know it's a 2. So we're going to group them in 2's. All right, I have a pair of 3's there, and that's it. All right, so whatever I circle goes outside the box. Whatever's not circled goes inside the box. And so this is what I mean. So you have, it's kind of like having a remainder when you, so here's my square root. The 3's are circled, so I have a pair of 3's. So what number is paired? It's a 3. So I'll put the 3 outside the box. And then what number is left inside the box, or whatever's number is not circled, those go inside the box. And there's my answer. So the square root of 27 is 3 times the square root of 3. And you can check this by taking this guy here, multiplying it to itself, which is 9, and then turn around and multiply to that and see if you get 27, which you know we do. All right, so let's try a couple more. We're going to try some, let's try this. All right, so we have 210, and we're going to do the factors of 210. So 210, I know since it ends in a 0, I'm thinking 21 and 10. This will be 7 and 3, and this will be 2 and 5. All right, so when I look at this, I'm going, okay, it's a cube root. Cube root, a square root, so there's the index is a 2. Do I have any that pair off? I don't have anything that matches, so this is simplified as possible. Now, you could put it in your graphing calculator and get an actual decimal. You could do that, all right? And so that'll work if you want to, but it would not be it'd just be a number that's rounded off. All right, so let's try another one. All right, so we have the square root of 72. All right, so I'm going to take 72. I'm going to find the factors of 72. It's 8 and 9, 4 and 2. This is 3 and 3. Remember, all these are really times together because you're just multiplying them all together later. 2 times 2 times 2 times 3 times 3. My index is a 2. See it right there? There's nothing there, so we know it's a 2. And so I'm grouping them in 2s. All right, now this time I have 2 circles, 2 groups. And what you do is you multiply the 2 groups together. So I have a group of 2s, and I have a group of 3s. All right, they both go outside. What's left over is the 2 inside. Now, I still have to simplify this. I just multiply this together. So 2 times 3 is 6. So 6, the square root of 2, is my answer. Again, we could check it by saying 6 times 6 is 36, times 2 is 72. All right, so what happens if we have a variable? So let's say that we have something fun, and let's put a variable in here just so we can see one. All right, so I'm going to do a nice big one here. Let's see. Okay, so I'm doing this one. Now this one, first thing I want to notice is my index is a 2. All right, so I'm going to do the factors of 82. So here's 82. Okay, so I know 2 can get, that leaves 41. All right, and so can 41 be broken down any further? No, so we're going to leave 81 inside the 82 left inside the box. All right, so 81 I cannot factor it, so 81 will stay inside the box. So I'm going to rewrite my box here. So 82 is inside the box, so it stays there. All right, now look at my index. I actually have 3 x's. All right, and I'm matching them, pairing them off in 2s, and there's 2 right there. So that means I have 1 outside and 1 inside. All right, do the same thing with y's. I have 5 y's. Match them by pairs. This time I have 2 y's outside, so that means I have a y times a y, which is going to be y squared. So because I have 2 y's, it's not 2y, it's y squared. So this would be, let me make some more room here, y squared. Because I'm multiplying y times y, and you remember when the bases are the same, you add the exponents, and that gives you y to the second. All right, and I have 1 y still left over, so there's still a y inside the radical. Now look at my z's. My z's, I have 4 z's. If I match them, I have 2 of them. Notice there's none left over, so that means there's no z's inside the radical, but outside the radical, I have 2 pairs of them. Now this would be my answer. Now a lot of times you would simplify the number and do the same thing with what we did with the variables. But now I do want to show you a shortcut. If you paid attention to this, you kind of notice that this is my index. If I take, let me put it up a little higher because I know that's right here. If I take my index and I divide it into 3, that means like 2 into 3. I get 1. That means I have 1 outside and I have 1 inside. See, I have the 1 inside. All right, if I do the 2 into 5, 2 goes into 5 2 times, and that means I have, and I subtract, it's just like division, I have 1 left over, so I should have 2 outside of the y, see there's 2, and then I have 1 left inside. And the 4, the exponent of 4, 2 goes into 4 2 times. That means I have 2 left over, which is right here on the index. Now, my final answer really is x, y squared, z squared, the square root of 82xy.